and welcome. My name is Quentin Nenon and I work at the Space Sciences Laboratory, University of California at Berkeley. And the story today is that the atmosphere of the red planet Mars leaks into space and it is deposited on the surface of the moon Phobos. And here is Phobos. You can see that it is very dark, there are many craters, and it's actually pretty small. So space close to Phobos is not empty at all. It is actually filled with small, invisible particles. So we have particles coming not only from the atmosphere of Mars, but also particles that come from the sun, because the sun continuously ejects in interplanetary space particles. This is what is known as the solar wind. Now, Phobos does not have any atmosphere to be protected against these small particles. So you can see here that it is directly bombarded by particles coming from the sun and coming from Mars. And the effect of these particles is that they modify the rocks that are on the surface of Phobos. But these rocks are actually very, very important because they hold the clue of the origin of Phobos. So if we analyze the rocks that are on the surface of Phobos, we can determine where this moon comes from. And this is such a big question that the Japanese space agency, JAXA, has decided to send a mission to Phobos. It is named the Martian Moons Exploration Mission, MMX, and here is the plan. It will take off from Earth in 2024, it will land on Phobos a few years after, and then it will collect rocks and bring back the rocks to Earth for analysis in 2029. But you mean the same rocks that I've just said are being modified by the small particles coming from the sun and coming from Mars? Yes. So we need to understand this modification. And the first step toward this is to determine how many particles impact the surface of Phobos. And this is a question that we can answer today, because currently in orbit around Mars, there is the NASA MAVEN satellite. And on board the MAVEN satellite, we have this kind of metallic box that you can see here. This is actually a particle detector. It is named static, and static is able to count how many particles come from the sun and come from Mars, and in the end, impact the rocks on the surface of Phobos. So it's really this question that I try to answer today. How many small particles impact the surface of Phobos as a function of longitude and latitude on the surface of the moon? So thanks to MAVEN, we were able to create for the very first time maps of how many particles impact the rocks on the surface of Phobos as a function of longitude and latitude. This is what you can see here. So here is the number of particles coming from the sun. And on the right, it is the number of particles coming from Mars. So now if we have a close look at these numbers, in particular, where is it maximum? So it is shown with the white color. You can see that the particles coming from the sun on the left and from Mars on the right, they impact totally different locations on Phobos. And by just finally determining how many particles impact the surface of Phobos, we have learned many, many things regarding how the rocks are being modified by the small particles. If I had to pick just one big conclusion that we have, is the fact that within the rocks of Phobos, we may have trapped some particles that come from the atmosphere of Mars. And we know which rocks are very likely to contain particles coming from the atmosphere of Mars. It's the ones that are located right here. So thank you very much for joining in today and enjoy the rest of your day.